another video. In this video, we are going to solve one question related to binary tree. The question is invert a binary tree. Here they have given a binary tree and we need to return the mirror of the tree. Invert refers to mirror here. As you can see in the example 1, where the root node is 4 and left is 2 and to the right 7 is there. And when we mirror, imagine this right arrow, there is a mirror and 7 will come this side left to the left of the root and 2 will come to the right of the root, and similarly this process applied to every other subtree. So we need to mirror a tree and we need to return it. So consider this very simple example where this has only root and root left and root right, and here after mirroring 3 will come to the left subtree and 1 will come to the right subtree of the node. So if root is empty, then we need to return empty tree. So we will start explaining with an example so that you can understand and we can come up with a logic to code this solution. As you all know, if you have only one node, after mirroring also, that will be one same node. Consider this example where it contains three nodes, root, root left and root right. When we mirror this tree, 3 and 2 will be exchanged. So consider another example where we have uh, child nodes for the apart from the root nodes. So we have 1, 3 and we have 3 levels. So after mirroring, so 3 will come here and 2 will come here to the right side and 7 will come here. Just imagine there is a mirror in the middle. So by this time you might have understood the process like what mirroring is. So we need to come up with a logic from where we can transform a tree from left side to the right side. And as you can see here, this problem appears to be in a recursive structure because each subtree will become a tree and we need to mirror that. So I'm copying that tree which is given in the question again so that we can understand the approach. So once we are at the root node, and if you consider this entire tree, it has many subtrees. So once we get the root node, which is 1, we need to take care of its subtrees. I am highlighting the right subtree and consider this right subtree. And once we mirror this right subtree, so this right subtree has one more subtree which is 7. So once we mirror 7, it will return 7. So this process here we need to exchange left and right. So if you consider the original right subtree of 1 and we should return 3 to the left of the 3, 7 should be there and then to the right 6 should be there. Consider this left subtree and if we mirror this we should return 2 and to the left 5 will be there and to the right 4 will be there. So once we get this mirrored left and right subtree, we need to assign it to the uh, corresponding left and right subtree. Consider this example. This is right subtree and once we mirror it, it becomes 3 and to the left it is 7 and to the right it becomes 6. So whatever I have highlighted in the red, it is after mirroring. So similarly, we started from the left subtree and once we mirror it, it becomes 2 and 5 will come to the left and 4 will come to the right. So we need to place these nodes to the um left and right. So we are going to take the, if root is null, we are not going to do anything. But if we have something to the left and right, we need to mirror it and exchange them. So how to write logic for this? So we know that our root dot right will be the mirrored version of our left. So this is what we are going to do in our coding. I'm going to write this below here. Our root dot right will be mirrored version of root dot left and our root dot left will be mirrored version of root dot right. So we cannot directly assign mirror root dot right here in the argument because it is already changed. So we need to store it before making mirror, before assigning mirror to root dot right, so that we can assign it here, so that we can use it here. It is mirror. So whatever it is there in the third line, it is not mirror root dot right. It will be temp. So we are going to code this solution and we are going to test this solution in the LeetCode so that I hope you understood the logic. Let us write code for this solution where whatever we have discussed, and we are going to write one more function named mirror where it will take argument as root, and it is be a recursive function as we have discussed because tree is a recursive structure. So what is our base case? If our root is none, if not root, then we are just going to return otherwise. So if we have something to the left and right, we need to mirror them and exchange their position. So our root dot right will be mirrored version of root dot left, and our root dot left will be mirrored version of root dot right. So our root dot left will be mirrored version of root dot right, but we cannot write root dot right as an argument because we have already modified root dot right. So before modifying root dot right, we need to store this tree in a temporary variable so that this can be used. So this is how we are going to mirror this tree, and we are just going to return, we're just going to pass the root, and let's see if it works. So here we are getting empty tree. Maybe we should return the root here because we are not returning root, so it is not returning anything. It's correct, but here we are not returning, instead of we are just calling that function. So once we return it, and we can see that first three test cases are passing, and we will submit the solution and check all the test cases are passing, and solution is accepted. Thanks for watching this video, and if you like content related to data structures and algorithms, please like, share and subscribe to this channel.